So now, good morning students. So here, first numerical, last class, on Monday we have seen two numericals based on the Kircoffs rule and Wheatstone bridge. Now again one more numerical, you are provided with the circuit. Here the battery is connected and then this current coming from this is given as 0.5 ampere and current coming from this is that you don't know. Now you have to find out this I2, this is I2 and you know that this I will be this plus this. This is I, if you consider as I1 as 0.5 ampere, I1 plus I2 is I. That is the thing. You are supposed to find out voltage drop across R. That is voltage drop across R. You don't know what is R, so voltage drop across R you have to find out. Then you have to find out current. Current in the arm EF you have to find out. Current in the arm EF you have to find out. These are the two questions you are supposed to find out. Now you have to apply Kirchoff's second rule. You have to apply Kirchoff's second rule for the mesh. If you apply for the mesh, this is we can start from this is the greater voltage. This is the greater voltage. You can take this as this greater voltage. You can take either this side or that side. Any side you can take. So now you can take potential drop across R. You have to find out. Now VB. Now you can take the closed mesh A, B, F, E, A. A, B, F, E, A. You can take A, B, F, E, A. Then you can take like that. When you are taking like that, then this will be that will be your VB. You can take from here. So VB. When you are taking here the current, you are taking the voltage current either right hand side or the left hand side if you are taking. So VB minus 0.5 into 2. 0.5 into 2. This is 0.5 only, here it will come. So that is why here minus 0.5 into 2. Okay. Plus here again 3. 3 is equal to plus 3 is equal to plus 3 is equal to VA. I repeat, if you consider the mesh A, B, F, E, A, when you consider, I am not applying anything here. I am not applying the voltage here. Only here I am writing this 3 voltage here. Only 3 voltage I am writing here. So here you see here, if I start like that, so VB potential at the, because you want voltage across this. So VB and current into resistance, either you can take it outside or you can take here. So 0.5 into 2, 0.5 into 2 plus 3 voltage is equal to VA. That is equal to VA you are considering. So now you can find out potential drop across R is, you have to find out, that is VB minus VA equal to what you are getting? VB minus VA is equal to, you will be getting this, you can take it outside, 3 and this is plus 1, that is minus 2 volt. VB minus VA is minus 2 volt. Or VA minus VB is, because here only the potential is small. So VA minus VB is nothing but plus 2 volt. I repeat, you are considering, here you are considering this portion, you are considering only this mesh you are considering. When you are considering, you want to find out voltage across this portion, voltage across AB you have to find out. So when you are finding out AB, what you are doing, that is here you are starting, because this is the high potential. So VA equal to VB, that this is current into resistance, minus, or it will become as VB minus VA, like that will become. So when it is coming like that, then you are getting minus 2 volt as the answer. That is, otherwise VB minus VA is coming like that, or VA minus VB is plus 2 voltage. So potential drop across resistor is now, potential drop across resistor is plus 2 voltage, because as are EF and upper row, because this and this, all these three are parallel. So V across R is because all the three cases are, these three are parallel. So you are getting this as 2 volt. V across R as 2 volt. Now next question, what is asked? They are asking I2, they are asking. So now you have to find out using Kircoffs law, Kircoffs rule at first rule and second rule. Now I am going to rub this. Now you have to find out I2. That is I2 you have to find out, which is nothing but I2 you have to find out. So VR you have found out as 2 volt. So now I am rubbing this, and then I am applying Kircoffs first rule for the mesh, for the junction E. For the junction E. For junction E, if you apply, see towards this I2 is coming, and away from this I1 is going. Towards this again I1 is, there is 0.5 is coming. So 0.5 plus I2, 0.5 plus I2 is equal to I. 0.5 plus I2 is equal to I. Now again Kirchhoff's second rule if you apply for the mesh F, this is junction rule, loop rule you have to apply, loop rule you have to apply for the mesh F, E, A, B, F. F, E, A, B, F. From where I am starting, there I am ending. So here you can take the other side, you can take, here you have started from F only. So here you can write this is equal to, that is 4 minus 3. 4 minus 3 is equal to, 4 minus 3 is equal to, you can write here, it is going like that and it is going like this now. So here minus, because when you consider like this, when you start from here, always if you start from here, so 4 minus 3 is equal to, here what happened, this is in the opposite side, so minus 0.5 into 2, minus 0.5 into 2, and here this is I2 along the same direction, so plus I2, plus I2. So here this is I2 minus 1 is equal to 1. So I2 is equal to 1 plus 1, 1 ampere. This is your answer. This is your answer. So you have to find out like this. So whenever you are finding out, this is at high potential, this is at low potential. First we have found out the voltage across. This is R. This is the unknown resistance R. So voltage across this you have found out. And here this is A, B, C, and this is D, E, F. So two batteries are given and one resistor. I1 and I2 is coming and total I is coming like that. And first case you are finding out this is at high potential, this is at low potential. Based on that mesh rule you are finding out VB minus VA or VA minus VB you are finding out. VA minus VB you are finding out. VA minus VB, you know that. Otherwise, you can use the formula, that is E is equal to V is equal to E minus IR. Like that also you can find out. You know the formula, based on that you are finding out this VB minus VA, and then you are finding out I2. I2 is nothing but this is 1 ampere. This is your answer. Now your second question goes like this. The second question is, you have to calculate the same circuit. Now I think you have understood this. Now the second question is, I am giving here, this is another circuit. These all questions are, this is given as 6 volt. This is given as 6 volt, and here 10 ohm is given. Here 10 ohm resistance is given, and here 2 volt. This is 2 volt, and then here again, this is, you don't know, unknown resistance R. This is unknown resistance R. Here one current is given as 0.2 ampere, and here also it is given as 0.2 ampere. Here also it is given as 0.2 ampere, and here it is given as one junction is given, and this resistance is 15 ohm. It is given as 15 ohm, and this is BA, and this point is BA, and then here again it is given as another resistance here, and another resistance here, another resistance here. So these two are, this is C, B and A. So here this is 5 ohm, this is 5 ohm, this is another 5 ohm, and between B and D, another resistance is connected, which is of 15 ohm, So this is a circuit diagram which is given, and you are supposed to find out R. This R you are supposed to find out. R, and the current in the circuit is already given, and potential difference between the point VAB. Potential difference across the point VAB. VAB is nothing but this potential difference. All these three are parallel. You can take these, all these three are parallel, and then you can start doing. So now here the total current is given as 0.2 ampere. Total current is given as 0.2 ampere, and now here, see, you can take 5, this 5, 10. These two are in series, so 10. And 10 and 15 parallel. Or you can take 15 parallel. 15, another 15, another 10. Or parallel. So you can take, this is 15, so 2 by 30, so it is 1 by 15, so 1 by 15 plus 1 by 10. So R dash is, I am not doing all the steps, this already you know. See, these two are series, 5 plus 5, 10. Okay, these two are parallel, so 1 by R equal to 1 by 15 plus 1 by 15, that is 2 by 15, that is 1 by 15 plus 1 by 15, that you will be getting, here you will be getting 1 by 15 plus 1 by 15, 2 by 15 you will be getting, and then again you will be getting one more thing. So like that you will be getting. So let me do it. So 1 by, you don't know what is R2. R2 also you have to find out. So you have to find out R, you have to find out. Okay. So now, first R dash is 10 ohm. These two are 10 ohm. Then this is equivalent to this. So here you will be getting this. This you will be getting. Actually, this is 30 ohm. This is not 15 ohm. This is 30 ohm. So the question I am repeating. See here 6 volt, and then here 2 volt is given, current is given, these three are given. So here you can take 15, 30 and 10. All the three are parallel. When all the three are parallel, 1 by R dash is equal to 1 by 15 plus 1 by 30 plus 1 by 10. So then you can take LCM as 30. So 2 plus 1 plus 3. So 6. 6 by 30. 6 by 30. So R dash is 30 by 6, 5 ohm. 30 by 6, 5 ohm. R dash is 30 by 6, 5 ohm. So this is the, what is that you are getting? This resistance across this parallel combination. You want potential across this. You want potential across this. So VBA is V into VBA is nothing but, you know that I is 0.2 into R is 5. That is 1 ampere. VBA is 1 ampere. Here it is, so it is coming like that. So 1 ampere. That means VAB is minus 1 ampere. Minus 1 ampere. 1 volt. Ampere is the 0.2 ampere into 5 ohm. So 1 volt. That is VBA. Now VAB is minus 1 volt. Because you are taking the reverse. Now that is the thing you have to find out. Okay. So now the remaining you can find out. R you can find out. Calculate the value of resistance R you can find out. Using the formula you can find out the value of R. Okay. Thank you.